I mean, obviously, every module manufacturer is doing a certain amount of due diligence, technical due diligence, with laboratories like RETC and working with inspection bodies like SDS and others to show and highlight that they're doing everything they can to supply you with a high quality product. What is not clear right now is how these module manufacturers are assessing long-term risks that these new modules are potentially exposing their customers to, which is the developers, the financial institutions funding these, and the insurance companies underwriting these projects. And so what we're setting out to do is to ensure that these risks are understood, tested, evaluated, and communicated to the industry. In this regard, we have developed a hail durability test program that took kind of like a side road, or parallel road to the certification process, and even the bankability process, similar to what we did in 2009 when we introduced the first bankability process, or due diligence process. What we're looking at is we're testing these modules. Any module that the module manufacturer produces, we will vet them and under different severities that will allow us to understand how they will perform and what risk they present under different conditions. Those conditions can be wide-ranging conditions that are preset based on available weather data out there, in which tends to cover the variety of different hail risks in the industry, or it could be specific to a project. I mean, we've had developers specifically ask us to assess the risk of particular modules for specific type of hail events, with the specific expected impact energy or kinetic energy from hailstones. But there are other risks that we're not talking about here today, which is something Daniel mentioned earlier with connectors, and other issues, diodes. I mean, when you think about it, like Frederick did a great job explaining what's being done to produce higher power from these modules. When you think about it, these module manufacturers are using similar connectors and cables, injection boxes, and diodes on a module that's potentially producing 10 to 20% more current. Now, imagine having to use the same connector and subjecting it to 20% more current, and a lot of the connectors are going to be doing fine, but what we're finding is a lot of connectors are not. A lot of the diodes are not able to withstand these hotspot events under really high current conditions, dissipating 20–30% more power from a string. So there are some issues happening, some risks, there with these technologies that I think you should take into consideration. And what we're here to do is really to help these module manufacturers assess their products and provide them with the technical due diligence reports that are going to end up on your desk to be able to make good, solid decisions based on actual data.